So today we're going to go over a short introduction to the final project. As mentioned in the email announcement I sent out, if you're not thinking about the final project yet, that's totally natural and totally okay. It's still a ways out. Doing this now, it would just fit well into the schedule and it gets it out of the way. And if you do want to start the project somewhat early, then you have some information to go off. So what I'm going to do here is just outline how the final project works. So I'll go over what's on the rule page. And then we'll take a look at the final project's, the project description, essentially then what the problem is that you're going to be solving. And then we'll take a quick look at the data set. And I'll just talk a little bit also about submission of the project and so on. Okay, so the idea is what we're going to do is we're going to take the information we've learned in the class, specifically different modeling techniques, and apply these to a kind of a real life problem using a real life scenario in some sense, using real actual data to write a report. In some sense, it's kind of an expanded version of what we've already been doing on the assignments and what the future assignments will be like as well. So the idea is we'll take a data set, which will be provided below, as well as a real life scenario describing a problem to solve. And then what we want to do, so we'll have a supervised learning problem in mind, and we're going to prepare a technical report modeling different solutions to that problem. So the idea is to try a few different modeling techniques and just take a look, play around with them in some sense, and see which one produces, in your estimation, the best results. So what are the techniques we have available to us? Well, regression and regularized regression. So if you want to do a simple sort of regression model, that's fine. Using a single decision tree model. Using a random forest approach. So I said this is chapters 10 and 11 because, well, bagging is kind of a special case of random forests. So in other words, using an ensemble approach with decision trees. Gradient boosting, which we're discussing now in class. So another approach with an ensemble approach with decision trees, as we've seen, quite a bit different than random forest. Also possible are the approaches that we haven't discussed yet, neural networks, which we'll talk about in chapter 13, and support vector machines, which we'll discuss in chapter 14. So you do not have to try all of these, but as the idea is to try 3 different ones, so at least you get some sense of what are some different approaches to the same problem and how do the solutions compare. So what you should do in your report is evaluate each model that you consider, decide how you're going to evaluate it, what loss functions that you're going to use depending on what you're doing, and then compare the results that you get and decide which model you think is best for the problem. Okay. You may want to go further than we have in, say, the assignments, where we have done minimal tuning, hyperparameter tuning, and so on. So you may want to consider tuning hyperparameters using grid searches, etc., to try and optimize your models. Then an important part of the final report will be an executive summary, which essentially should be answering the question in a less technical way than, say, the main body of the report. So you start with an executive summary, summarizing what you've done, and trying to explain it in a non-technical way to a client. So what we'll have is the actual project itself will be kind of based on, here's a client asking you to do this problem, and so then the idea is you're preparing a report for that. That's kind of the setup. Okay. We'll get to that in a moment. But anyway, so with your project, you should have an executive summary. You should have a kind of main body of the report that's more technical, especially include various graphics and so on. And then any sort of extensive R code that you're going to include should be in an appendix, along with any other very sort of technical coding type aspects, anything done in Excel, et cetera, as well as citations. We'll get to that in a moment. Okay. The due date is not set yet because we're waiting for the official exam schedule to come out. It will probably be Friday, April 29th or something thereabouts, towards the end of the exam period, but I do need a few days of lead time to grade them. It's possible it may push through that weekend. We'll see. So somewhere around the end of April and start of May. depending on the exam schedule and also when the final grades are due. Yeah, lost my train of thought. Okay. So the way we'll submit it is there'll be a final project report Dropbox, and you run it through that with the turn it in feature, which does sort of checks for plagiarism. Now, it is perfectly fine to have quotations in your text from other sources, but when you do this, you should cite them. Okay, so if you are going to quote any text in chunks, cite the source that it's coming from. That certainly is not plagiarism, just actually copying material without crediting it is. Okay, so be careful about that. I haven't had any issues with this on previous final projects. So there's the Dropbox final project final report Dropbox. Okay, and then the date will be given there. The idea is you'll be able to submit it from any time from the end of the semester onwards, if you want to get the report done early. As mentioned, include any references such as documentation for R packages, information associated to R, anything you search up online about how to do a particular supervised learning technique in R. You can include that in your citations and your references. As mentioned, if you have extensive R code, you want to include that in the appendix, not in the report body. Now, in the body, you can, of course, include references to R, such as what packages you're using and so on, and short bits of code, but any large blocks should be in the appendix. Now, there's also a sort of project outline / proposal, which is due Friday, March 11th. That can potentially be pushed back a little bit if needed. This is not getting very long, so the whole idea here is to get you just at least thinking about the project by then. And what you want to do is provide, say, a title, and then a short summary of what you think, like how you would describe the project objective. So not just copy pasting the project description, but just a kind of quick description of how you would interpret the project. And try to explain one modeling technique that you're planning to use. You don't actually have to use it in the project, but do think about ahead of time what's one technique you'd like to try and why you think that might be a good approach or a good technique for the data set and the problem we're solving. Okay. And then any citations that you are planning to use if you have any. So this project outline is not going to be very long. It should be, it certainly shouldn't be any more than a page, and probably, I mean, depending on spacing, but maybe a half a page would probably be sufficient. It's just to show me that you've actually you've read over this and you've thought about the project a bit, and gotten kind of just mentally started on it. Even if you haven't really done much work, that's fine. Okay, so here's how the grading will work for the project. It's out of 35, since it's 35% of your grade. The outline is out of 5. The modeling aspect, evaluating, and comparing your models is out of 10. The executive report is out of 5. There's 5 points for professionalism. And then overall quality, which is simply my kind of evaluation of the project, is out of 10. All right, so here are the resources for the project. There's the project outline Dropbox, the final report Dropbox. So you'll submit your outline at the first Dropbox and the final report the second one. The description for the project, which is in a PDF that we'll open in a moment, and then the final project data set, which is an Excel file, a .csv. And then the video going over this will be posted here, along with the lecture sequence at the date we recorded it. So if you want to refer to this, it will be there. At some point, that link will probably be replaced with an actual file of the video. And this is for technical reasons related to Collaborate that I'll discuss a little later in the course. So just watch out for that. It may just end up being a video that you can download. Okay, so what we want to do now is look at the problem description and then take a quick look at the data set, just to understand. We're not going to, of course, we don't want to read the data set. We just want to take a look at what is it, how big is it, what are we sort of dealing with there. Okay, so let's open the project description, which is here. So here then is the description for the project. It says, Danielle Henderson is a realtor at Century 21 in the Chicago, Illinois metropolitan area. She manages a large real estate portfolio of different housing properties in the region. She has assembled a database of information both on properties she and her real estate firm manage or previously bought and sold. Ms. Henderson has hired you to analyze her data and provide insights into how the various features of the properties in her data set affect the selling price of the housing properties that she manages. She would like you to formulate, train, and consider predictive models for the selling price using several different machine learning techniques. Okay, so notice then selling price is going to be the target variable. So this is a quantitative variable. In other words, we're solving a regression problem, right? We're solving a machine learning problem where the target variable is a numerical quantitative variable. Okay, so it says she would like you to prepare a technical report explaining your findings. It is up to you to determine what aspects of the analysis you would like to focus on, but some possibilities include looking at the overall predictive error, differences between training and testing errors, measures of feature importance, and the advantages and disadvantages of different modeling techniques with regards to this problem. Be sure to make a judgment on which of your models is the optimal one for this problem and why. Your report should include an executive summary which is comprehensible to a non-specialist such as Mrs. Henderson. All right, now you'll notice then this problem has a lot of similarity to the Ames housing data problem that we've encountered in class, and that's not an accident. It's a very similar data set, as we'll see. And so part of the point was to choose a data set and problem which is something familiar, somewhat familiar to you, reminiscent of something that we've covered in class. So if you go and look at the different times we've encountered the Ames housing example and what we've talked about with it, you'll find, I think, that will be helpful in terms of kind of providing some guidance to what you might try with this project. All right, so let's take a look at the data set. Get an idea. As mentioned, it is similar to the Ames data. So it's a large CSV file. There are 82 columns, the last column being the sale price. So sale price here, the final column, that's our target variable. The other 81 are features. So again, it's pretty similar in terms of number of features to the Ames housing data. And there are 2,931 rows, so a little under 3,000 data observations, each row being, of course, a data observation, which is also fairly similar to the Ames example. You'll notice going across the rows, there's both qualitative, categorical, and quantitative numerical variables of different types. You may want to read through and understand what some of these are. You don't need to be too concerned with what each variable is, but if you're some of the names should be fairly clear, such as street, utilities, condition, and so on, neighborhood, overall quality measures, etc. If you are unsure of what a particular feature is talking about, you can feel free to ask me. I don't have a code book offhand available for it, but I can certainly come up with some answers there if you need them. All right, so that's the data project. I would encourage you, if nothing else, to do a training testing split at some point in your project when you're training your models. So you save some of the data as testing data so that you can look at the training and testing error. Do think about maybe tuning hyperparameters a bit more than we have in the assignments where that's usually not brought up that much. So all the assignments, well, if you've done them so far, you might find that they're relatively quick. They're not too long, and so we're going further on this project. That's the idea. The assignments are kind of warm-ups to get you used to just what's some of the basic syntax for these modeling methods. But if you want to go further, such as getting into changing and tuning the hyperparameters and running grid searches, information about that is easy to find in the textbook online, and so on. And I can help you with that as well. Okay, so that's all I wanted to say about the project for now. But if you have questions about it as we go through, anytime and you start working on it, please feel free to ask me, and I will help you out as much as possible.